Thank you, everybody, for the introductions and welcome to this workshop. This is perhaps the inaugural day of the workshop, and I thought in terms of approaching doing a hands-on workshop, we'd have try and do a first look at generative components. Generative components is a product produced by Bentley Systems, and I work for Bentley Systems. I've been with them for 14 years, and have had an education in architecture, and in my working life, I've covered a whole series of different activities. And now my role is to do public events and public speaking about various aspects of Bentley software. And what I'm going to be talking to you today is about generative components. So this is an opportunity to do a little bit of hands-on experience with generative components. I just want to do a quick check with people. We did send out some links for people to download the software and install the software. I mean, there are a number of what I would call design computational tools around in the marketplace. Generative components goes back nearly 15 years or more, and the way that we view a computational approach to design, I guess, can sort of be summarized by some of the statements that you're seeing on the screen. So, but not limited to these, by the way. So again, when the sort of standard CAD tools for perhaps the mainline or production of information aren't giving you what you need, they're not allowing you to meet the desired deliverables, and that you need to develop a workflow or even explore an idea, then there is a potential opportunity to look at a computational approach to a task or a workflow, or the exploration of an idea. Obviously, when you're exploring that idea, sometimes your research takes you in a direction you may have not been able to predict, but at the start, at least, you may anticipate that there are some predictable ranges of behavior, or predictable or acceptable changes in geometry or data, etc. And you want to examine or explore those data and then capture not only the process that you used, but also the outcome of those processes. Obviously, in that, you're going to be wanting to explore variations so that you can make informed decisions about design outputs, etc. And so you can see here how we've sort of summarized these items. And if you need to examine any of these ideas or processes in combination with other outcomes or processes, etc., then that sort of lays the foundation for when computational design might be an avenue to explore, to look at what you want to achieve. Okay, I think that's fairly accepted across the industry now. The use case has been explored and developed, and I guess going forward with this conference, as it develops over the years and it broadens out its reach, then perhaps we can revise this basic list and add to it in some way for future use cases, etc. Okay. Today I saw as an opportunity to expose people that might have not used computational design before that might have used computational design tools from other vendors and may not be aware of generative components. So I wanted to sort of introduce the software, talk about some of the techniques that are common across multiple vendors, because the mental language and the thought processes that we need to apply have certain common lexicographies and dictionaries in terms of approaches and ideas. And I just wanted to, for new users at least, expose you to those items. But if you're an experienced user of other tools, then it was an opportunity to expose you to the way that Bentley have interpreted and implemented approaches to those ideas, those dictionaries, those lexicographies, etc. So I'm going to focus on 3 aspects. I can't show you everything in the time available. By choosing these 3 topics, I'm trying to give you an overview of some of the range of possibilities and different types or ways of approaching computational design that is available in GC, but you may find similar approaches in other tools as well. Okay. So I have quite an extensive PowerPoint that I will share with people or make available after the presentation, and it will be in PDF format, and it will be an aid memoir to things that I'm going to talk about and to things that I'm going to illustrate. But it's not going to be everything I talk about. It, like I say, it's some visual aid memoirs, but there are a couple of exercises in there, and I've just briefly summarized the steps that I'm going to do in those exercises to create various things and illustrate various arguments. So with that, I'm going to sort of dive into the hands-on approach. Again, if you want to follow with me, I guess you use the chat or open up your mic to interrupt me, tell me to slow down or repeat something. You know, you're quite welcome to do that as well. And I'll keep glancing at the chat window to see if there's anything available in the chat window. Okay, right. So let me just start up generative components. Now, when you install, here I've just launched generative components. I'm not going to go into how the application is set up or configured. I'm just going to dive right into the application. Now, I'm choosing some preset settings up here. Now, depending on what you've installed, you might see a different list. Just to let people know that if you see something called NM, it means neutral metric. So that is a metric system-based file and configuration. If you see something called US, it is the US-based configuration, and that has imperial units. Regardless of whichever you have, we can create a file, we can change the working units into that. But essentially, just choose what's available there, and then just click the new file command icon there at the bottom. Okay, opens up a dialog box like this, and we can just create a file, and we can call it whatever you want to. I'm just calling this interface, if I can spell. Okay, and just click save. And what that will do is it will launch the application. And in the background, what it's doing is doing some presets and some configurations, and it's going to present a file on the screen. So we'll give it a second to load. And whilst it's loading, once it's loaded, I'm going to walk you through the principles, not only of the interface, but some of the using aspects, the usability aspects of how GC works. It sits directly on top of a full 3D design tool, and it can leverage files created by that design tool. It can leverage files created by other third-party tools as well. And we can interact with those to greater or lesser extents. And there are different ways, like I say, of exploiting the interface so that you can begin to build a solution to, or rather an exploration to derive a solution from an idea. So when you first open the application, you may see a layout similar to this. So in this area, okay, I have a window, and this is the window where all my graphics are going to appear in 3D. Okay, I can actually have multiple windows open, and I can arrange them any way that I want to. So I can have an isometric view, I can have a plan view of any geometry that I'm going to draw, and I have different ways of representing that. So I can have a wireframe view, I can have a shaded view or an illustrated view, etc. And all of the geometry and the settings that I'm going to generate are going to appear in these windows up here. And you can open anything up to 8 windows, depending upon how you want to view things, or how much screen acreage you have. Okay. Then down at the bottom here in this gray window, this is my graph area. This is where I'm going to build the visual programming, the visual diagram of all the decisions and inputs and relationships that I want to explore and examine. Now, using a graph or a node tree, excuse me, is a common idea amongst lots of computational design tools. And ours is a window that can sit below these items, but we can also detach it and move it around and have it positioned anywhere on the screen. So as I pick up a dialog box, you'll see these docking controls that allow me to position wherever I want my graph window to appear on the screen, and it will just dock the items wherever I want. Okay. At the top of the screen, I have, you know, a typical Microsoft based or a Windows based ribbon system, and I can move between those ribbons and get access to various commands. The home command gives me access to a lot of icons for GC specific activities, and we're going to look at a number of these over the next hour or so. Okay. What we're also going to do is look at other aspects of this. So for instance, at the moment, this is what we call the transaction window, and it's empty. And this window, a little bit like the graph, builds as we explore ideas and we explore geometry. This transaction window becomes our history of steps and actions that we take in order to build our graph, as it were, and I'll come back to that. Again, like this, you can choose where you want to put it. Typically, I have it over on the left-hand side, but that's just my personal choice. Then the last thing I want to look at is let's see, the node types. So this dialog box, and you can find it up here in the primary toolbox. These are a list of our nodes that we're going to build in our graph. Okay, and it's split into 3 areas. Okay, so we have general geometry. So this is where we're building, I guess, what you might think of as traditional 2D or 3D CAD elements. So these are lines, curves, basic pieces of geometry, arcs, ellipses, circles, but there are also more complex things like polygons, planes, meshes, B-spline surfaces, solids. We can also look at things like text, and that's what we class as geometry, and I'll come back to that. We have a second panel, and because Generative Components is built on our Open Buildings tool, which is our 2D, 3D vertical construction solution. I guess that's akin to the likes of ArchiCAD, Revit, Allplan, etc. What we have there are nodes that allow me to build pieces of geometry that reflect the nature of a building. So we've got things like walls, we've got structural members, we've got freeforms, we've got mechanical items, we've got grid systems, etc. But we also have things like drawing production control. So if I want to automate or control drawing production, where I'm cutting a section or extracting a drawing from things, we have some solutions here in the node panel for that. Okay. Lastly, and I just want to cover here that we have a utility panel, and this gives me items that don't fall into the previous 2 categories. Okay, so these are extra nodes that we might use to control inputs or outputs from our decisions. So we have things like the ability to create scripted functions. We have the ability to export data to other formats. We have ability to import data from other formats. So we can link to databases, we can link to spreadsheets and things like that in order to drive data or to generate data out or to consume data into as an input. We also have some techniques for controlling things by law curves, and we have and we're not going to have the ability to cover all of these different nodes in this session. That would just take too long, and it wouldn't make much common sense to do that in terms of giving you an overview. But I just want to highlight that these things are here, so if you want to do any future explorations, you can do. We do have an optimizer node, and what that allows users to do is to run through a number of iterations to take a small input sample set of various inputs and perform calculations based on those inputs, and then look at statistical results over a range of possible inputs and outputs to choose what might be optimal in terms of the combination of inputs to give you a range of optimized outputs. We won't be covering that one today, but it is quite a valuable tool when you're looking at perhaps examining the best number of inputs to give you the best or the optimal number of planar pieces of geometry, say for a curved surface, so that you can choose what gives you the optimal output for that. So we have things like that. We have the ability to color code items based on values, etc. And then there are a couple of control inputs here, such as sliders, values, and operations. And we will touch upon some of these during the course of this morning. So this is our node panel. And again, like the others, you can dock this wherever you want to. Now, I've done that, and you can see it's put it side by side with the transaction tree. That's not necessarily an efficient use of screen estate. So I can actually take this up and actually drop it on top of the node panel. And now what I get are two tabs down at the bottom of the screen here that allow me to click on either of those little tabs and move between those two dialog boxes to see what's going on. Okay. Now, in terms of beginning or interacting with the software and beginning to build something, there are some key principles that we need to look at. And in terms of being able to control what we're building, how it's orientated, how it interacts in our minds in terms of the real world. The design file that we're in, the container for this information, it has the concept of an XYZ location, just like every other CAD system in the world. But we need to formalize that we're using that standard coordinate system. And so in 99 cases out of 100, we always begin by creating what we call a base coordinate system that establishes and drives all the geometry. Now, there are a couple of ways of doing this. Okay, and this sort of illustrates the flexible approach to how we might use GC. So if you look on the node type graph, the way that the node type graph works is I can find, for instance, my coordinate system icon, and if I hover over it in the node graph, which is a little triad, an ACS triad that you might be familiar with, I get a little pop-up giving me some information about that item. And I can click on that item, and in that graph window, okay, it appears as a node in that graph window. And I'll come back to the structure of that. I can right click on it and actually delete it. I could, in theory, with some of the nodes, drag them into the window. However, with that node, we can't do specifically, because what I want to do is actually go up to here, and there is a specific tool at the top here that says, oh, I want to create what we call a base CS. Now, this is a protected and standardized item. So again, when I click on that, it says here, sorry, I apologize, I'm just moving it across off the screen, is do I want to put this at the origin of the file that I'm in? So yes, I do. And it goes in. You notice it looks slightly different because it's a very specific base ACS. Okay, again, I can't drag that in, but if I go up to the top here, there is a second ACS triad icon. And what I can do is click on that. And now what I do is I get a coordinate system attached to my cursor. And if I place this down, I can place this anywhere randomly in space. But when I place it, you can see it's automatically building the graph for me. And it says that there is a relationship between those two items. And you can see the relationship is indicated by the item. And if I just focus in for a second on this, zoom in, and perhaps if I just tidy this up again, make this a little bit bigger for you, and just so you can see this. You can see I can zoom in and zoom around the item. When we pull in a node graph, there are various things happening on this node graph, and I'll come back to this. But at the moment, I just want to explain, it says by Cartesian coordinates. This is the technique or the method for creating this object. And what it's looking for is an offset in the X, Y, or Z location from another point in space. Now that point in space is defined by my base ACS. And currently, because I manually placed that item using my cursor, it's indicated by this free word, which is a keyword, and then the numerical value for the X location of that object. And you'll see similarly for the Y and similarly for the Z. They're all free, and then they have numerical value. Okay, so if I just come off that for a second, zoom out, okay, do that. Now, what I've done there are two steps. I can then choose to record those steps using my transaction list. Now, there is an option to automatically record these, and it will give you every step that you've done. Here I've done 2 steps, but I also control it manually by clicking here at the top. And what that does is it creates an entry here in my transaction list. The transaction list is my history of what I've done, and I can actually unwind and rewind everything through that transaction list. So I've just unwound back to the beginning of the transaction list, and I can then play forward the same transaction. And what's happened is the same 2 nodes have been created. You can see them graphically on the screen, but most importantly, they've been created in exactly the same condition as when I hit the save transaction. So the transaction list there is something that is very, very useful, and we'll come back to that as well. Okay, we're going to be using this later on as well when we look at this. So there are, again, so once I've done this, what I can do, and if I just put this up there out of the way, is I can look at begin to draw things. Okay, now you'll notice there are a number of tools up here, things like points, things like lines and B-spline curves. To get you started very quickly, what you could do is to learn how things are done. Okay, so let me just, you could use some of these tools to get started. So for instance, if I wanted to create a line object, okay, I can click here and I can then click on the screen and draw a line using the standard techniques that I would use to input a line. Say I want it 10 meters long or something like that. I can input that. And what it's automatically done there, if you just put this to a side for the moment, is it's actually created a point at the beginning of that line, a point at the end of that line, and then it's joining those 2 points in order to actually create the line. So a line has a method or a technique called by points, and that technique or method is looking for a start point and an end point. And that's probably the simplest way to actually visually or programmatically describe how to draw a line. Okay, and so it's created that item. Okay. Alternatively, okay, I can go into my node type command here and do the same thing. I can click on a point item and it goes into the node, and I can click another point and it goes into, it goes into the graph, and these are linked back again to the base ACS for a moment. Okay, so they have an offset from the XY location. Okay, but what I can do, and at the moment they're actually on top of the, the origin of the file, so they're actually zero translation. But I can actually go in here and I can type things. So I can say that this one is 5 meters in the z-axis, go down to here and say this one is 10 meters in the z-axis. And now you can see if I select and highlight those, I can see those 2 points there in space. And if I wanted to, I could then create a line by just clicking on that icon, dragging into the graph. It's defaulted to start point and end point, and then I can link them together. And now I have a line. Okay, so we're giving you a number of different ways of interacting between creating geometry, using the node tree, using free space, and controlling the free space to do that. Now, if you look, I apologize if it's hard to see, so let me just change the display style, and let me just change the view properties to switch off that grid, which is just a visual aid. It's not actually doing anything. You can see that I have a point here that has a cross on it and a corner bracket on it. But I also have a cross here that represents a point. So, this is a point, and you can see it highlighted in the tree. But this is also a point, but they have different icons. And the reason for that is it's to do with the status of the information here. So, like I said, in this item, when I look at these properties, the X, Y, Z, these properties still have the status of free. They have been randomly placed in space, and the icon indicates that those properties have been left at free, whereas the icon here indicates that one or more of those properties has actually been specifically, if you apologize for my language, specifically specified. Okay. And it's been fixed, and it's limited to a specific value. So at a glance, I can see there that there is specific information about those 2 points that somebody has input, and I can then understand that they are controlled in some way. Okay. If I look at a geographical coordinate system, so remember this is a coordinate system. Okay. There are various aspects to this. So for instance, over here, there is a short red line, there's a short cyan line, and a short green line over here. These are directions. So that's the X direction, that's the Z direction, and that's the Y direction. These are all properties of that coordinate system. So the coordinate system, its internal structure, it understands if I refer to the Z direction, it knows the direction that I'm referring to. And similarly, beyond that, you then have a series, and I know it's hard to see because they overlay one another. Let me just see if I can just rotate this to give you a better view. But there are also 3 planes. There is the the XY plane, the XZ plane, I think, and then the YZ plane. Okay, and again, these are all properties of that coordinate system. And if I want, I can use any of the properties of that coordinate system to control other geometry. And we'll come back to those items later. Okay. So I've given you 2 or 3 different ways to, sorry, two ways to draw a line. The last way is to actually physically draw a line. Now, when I was using this tool up here at the top of the screen, sorry, oops, sorry, I do apologize. These tools are up here, okay, at the top of the screen there we go. They were actually directly creating nodes in my graph and elements in my graph. Whereas if I type the spacebar, I can actually draw just simple dumb geometry, such as a line or even a rectangle. And this is a CAD element. It's not a GC element. So again, if I go back to my transactions, record all the transactions, undo them, those elements are not linked to the graph. They are physically present in the file, and I can then choose to play back my graph to see those elements. So in many ways, the elements that you're creating, you can think of them as being transient elements. They are created in the memory of my design session, and they are displayed. So if I then want to use this information downstream in another package, I would have to actually export this information and fix it, separate it from the node tree. So I would output it as a standard representation so that other people can then interact with that geometry. So that's another thing to consider, how and when you want to iterate and output downstream for other people to collaborate on. Okay, and that's a long-term goal, a long-term aspect of design consideration and design process, excuse me. Okay, so I've got these two elements, but if I want to use these elements in my design, I can actually promote these elements from being standard CAD elements into a definition that is included in my tree. And we have at the top of the screen here the promote element command. Now, the scope of this tool is to essentially look at what you've drawn, find the nearest element type that GC understands and the nearest technique to create that GC node, and use that to replicate the geometry. So if, for instance, if I click the line command again, what you can see is I get two new nodes, and I apologize, there we go. I get a new node here, and it's connected again to a start point and an end point. And it's automatically named the nodes, and it's generated a new node output. And again, they're in the tree, they're linked together. If I do the same thing, okay, with the rectangle, what it does is it creates a series. Well, what it actually does is the nearest element type it understands is a polygon, and the polygon could be multi-sided, but the technique it's used is by vertices. And in order to pick up the vertices and to describe the polygon, it's actually inserted and calculated and placed a point in the position of the original rectangle there. Okay, and so it's applied the nearest and simplest approach to do that. So again, if you've been doing some hand sketching in terms of an idea you want to get, there may be a possibility for you to take that hand sketch and convert it into a node tree, and then be able to control it and adapt it and amend it using that node tree. Okay. We can record transactions, and you can see I've got, you know, very quickly I've got the basis of a node tree here, and I've got a list of transactions. And like I say, I can unwind them, but I can then play them back at, you know, one at a time. Okay, so this is actually really a really powerful tool. Behind this transaction is a series of scripted items. So if I right-click on that transaction, I can use the command edit transaction. And what it does is, and I apologize, it's just opening off screen again, bring that in, is it's creating a text script that describes how to create that item. And so what it's done is it's created two nodes. I can see that here by the keyword node, user, object, base ACS. And the base ACS is the name, coordinate system 1 is the name, and you can see those here. Okay. And it then gives the node type, the programmatic name for that node. Here you can see that there. And then it gives me the properties for that node. Okay. Okay. Graph location is just the XY location of where that graph is currently stored in that graph window. But you can see here, I've got the XYZ properties that are on these inputs here, and they're replicated up here. Okay, so if I just close that, I haven't made any changes here. Okay, but what I can do is I could, if I wanted to, edit these values. So if I said this was 1000 by 1000, oops, sorry. Okay, and apply those changes. And replay that command and fit the item again. If you zoom in there, you can now see I've physically set the location of that coordinate system, and it's using that XY item. So this little script is editable and you can control it if you are comfortable doing that. But by the same token, it is tied into the graph. So if I make another change here, okay, that edit there is essentially a change that I have made after that item was recorded. So if I now record a transaction, it's actually created a new transaction here to actually record the fact that I've done a physical change on the object since it was created. So again, if I unplay the item, it reads the value in the script, and the value in that edit window is still 1000 by 1000. So it reads whatever is edited in the script, but then I've recorded a transaction here that changed the value on this node using the interface here, and it records that as an action, and it puts that node back to that new location. So the transaction list is a very, very powerful way of looking at all the steps and all the changes that you might have done whilst you're examining an idea. The beauty of it is with the transaction list is I can do other more complex things. So for instance, there are two steps. If I play this first action down, there's a little plus sign next to it. And I can see there are actually two items recorded in that one transaction. They're broken down here. Okay, there is the base CS, and then there is the coordinate system 1. So it creates the base CS and it creates coordinate system 1. Okay, what I can do on the transaction is, because I want to edit one of those items inside that transaction, I can actually split it. And this is okay, you get a little warning sign. You have to have played the transaction first. So let me just play it. But now that I've played it, I can actually split that transaction, and it's non-reversible at the moment. So you can't use, undo to reverse it. But I can then split that into two separate actions. So now the creation of that second coordinate system 1, is an individual step in the transaction tree. And once I've done that, I can treat it as a separate transaction. So I can actually do things like rename the transaction to make it something more meaningful. So, whatever you wanted to do. So you could say blue origin, something like that. You know, whatever mental approach or philosophical approach you want to apply to naming your transactions, you can do by simply renaming the transaction. But alternatively, what I can also do is highlight the transaction and delete it. Once it's deleted, it's removed from the memory, from the, you know, the algorithm that we're using. So now if I play back everything again, you can see that that coordinate system, oh, I do apologize, it's popped back in. I didn't delete that correctly. So let me just delete that transaction. Yes. Okay. Do that. Apologize, that coordinate system is coming back. Again, why did I do that? This, yes, where is it coming from? Okay, that coordinate system one, because I created and modified it in a future step after I deleted it, it has actually reappeared. So again, what I need to do then is split this transaction. Okay, and you can see the add coordinate system one is there. I can delete that. And then make sure, change that, delete that again, play that back. You can now see that coordinate system has gone. Okay. And I can, like I said, undo, reback and play again, and everything is back where it was. All right. Just one or two more final points. One of the big things I could say about items in GC, all our nodes, is they have a lot of properties and a lot of different techniques. And we don't need lots of different nodes to do lots of different things, because we can exploit the properties of an object. So let me just unplay that transaction for a second, delete that one, just to simplify things. And I'm just going to get rid of these elements. Okay, let me just, okay. So I have a line here. It's called line 2. Okay, and you can see that there are inputs, start points and end point. These are also properties for each of these lines. So if I wanted to create a new line, okay, I have a choice here. I can go to a line here, and you can see it has start point and end point. If I was just to do that, okay, you can see, hang on a sec, how can I have a new line that is drawn? How does it understand which end of line 1 and which end of line 2 is it drawing the line from? Because there are 4 opportunities there, okay? And it doesn't know which of those 4 points it's trying to use as the start point. And similarly, it doesn't know which of those 4 points it's using as the end point. So there are 2 ways of controlling this. So let me just detach those. Okay, first thing I can do is I can look at my outputs. Okay, and I'm just clicking on the right-hand side of my node there, and I'm going down and I'm having a look there at the properties of the object. So for instance, here, one of the input techniques is start point and end point, but I can also use those as an output. So I can just pin one of those. For instance, just click on that pin and you can now see I've now got a connection point on the right-hand side of my node, and I can connect that to the start point. So that's technique number one. You look at the properties of a node and then you expose the property that you want to use downstream by just clicking on the little pin icon in order to expose that property. The second thing is we can do is we can actually go to here, and where it says, you know, because previously we had that situation going on and it doesn't know whether it's using the start point or the end point of line 2. But what I can do now is, instead of having to open up the output point on the node, up in here in this text box, I can begin typing a dot. And what it does is it goes, if I put a dot at the end of line 2 here, it then gives me a drop-down list with all of the possible properties available from that object type. So I can manually scroll down and find start point, or it will auto suggest. Once I get used to this, if I start typing STAR for start point, it finds it in the list and I can just hit enter and it will auto complete that. And then if I hit enter again, it takes that value and corrects it. And I know that I can then build the new line. You can see it over here based on those two inputs. Nearly everything in OBD has properties that we can use. So I don't need a vast library of different nodes for different properties and objects. I can exploit those properties here. And you will get used to learning what properties are available on what nodes, just as you will get used to what techniques are available for different nodes. Okay. So, and it's very flexible then. For instance, I can then reverse this and say, oh, actually, I want it to go to the end point. And do that. And you can now see I've been able to change it very quickly. Okay, again, just by changing a property down here. Okay. So that very quickly was an introduction to the interface, ways of interacting with the software. What I want to do now is go on to using these techniques to create something called a user-generated node type. So let me just zoom through this. So like I say, in my PDF file that I will share it, there are just some little pages with some visual aid memoirs to talk about the kind of things that we're looking at in terms of transaction lists and things like that. There are some things that I haven't talked about. The fact that you can, for instance, you can suppress and unsuppress items. So for instance, if I built that list there, steps 1 to 18 to get to a certain point, but what I wanted to do was do exactly the same thing again, but introduce variations and ignore steps 8, 9, and 10, I can actually suppress those so that they are not run, do some more steps, and basically build in or examine a variation without having to build the entire script from scratch. So transactions are very, very interesting. So we were looking at node types, and we were using the standard delivered nodes like place line, place point, etc. But there will come a time where what you want to do is, you know, you have a design situation that you're going to use frequently, or there's you want to build a component, your own node type, that you want to use inside another script. So a node type can be, like it says here, it can be modular and reusable. It could be a very tiny little script that you want to use in a larger script. So, you know, you can begin to take like a system of systems approach to, you know, answering a design problem or examining a design idea. And this is where generated node types can come in, because you can encapsulate a construction of some kind or an activity of some kind, and then package it and make it available to one or more users on different systems. And as part of that process, what you are doing is you are predicting and analyzing and deciding what the inputs, what the, you know, the upstream influences are on your generated node type, and you're outputting information for downstream use by the rest of the script. So it's a very sort of graphical way of being able to componentize and break down large complex ideas into pockets, I guess, is one way to think about it. Now, for this, I might have to jump backwards and forwards between pages in my GNT, sorry, in my PPT and the application. So hope, excuse me, you bear with me. So what we're going to do is we're going to create a little usable panel, perhaps a cladding panel or a curtain wall panel that has a very basic structure on it. But what we want that panel to be is responsive to a larger system of panels. So what I might do is I might create the system that controls the overall shape and nature of that curtain wall in a different file. But what I want to do is take the file, take this panel and replace or utilize that panel in that other system. Now, the example I'm using is talking about doing generating a node in one file and then generate and using it in another system. You can actually do this in a single file, but for clarity and data cleanliness, I would just suggest that we use separate files. So the first thing that we're going to do is we're going to create a new file, and we're going to begin controlling the creation of that base panel. And we'll get to, you know, explore new ideas and some new concepts in GC beyond those I've mentioned already. Okay, so I'm just going to jump back to this and literally go to the top here and create a new file here, and I'm just going to call it, sorry, just bear with me a sec, GC_crossbar. Okay, so I'm going to save that, And it just gives me a clear slate upon which to build my idea. So generally speaking, there are a number of things that we need to bear in mind. For this exercise, we're going to assume that the curtain wall panel is going to be roughly rectangular. It's not going to be diamond shaped. It's not going to be anything too difficult, because it's just a simple example for teaching purposes. It's going to have an element of some crossbars in it, hence the name crossbar for the file. And there's going to be some glass in this panel. And what we want to do is we want to be able to control, when we use this in the system, we want to be able to control either the radius or the diameter of those crossbars, so that we can obviously control the look and feel of the system. All right, so I'm just going to close these windows down and just maximize this. So again, we've got a clean state. And as before, essentially what we want to do is we want to initialize our base ACS. This is really, really important principle, because we do a lot of geometry that is offset from this base ACS. Okay. Now, if you remember, I said when we have a coordinate system, there are a number of planes in that coordinate system, and they are properties of that coordinate system. Now, what I'm going to do is I want to create a series of points that represent the corners or the vertices of my panel, but I want to roughly build my panel in the vertical plane. So I can do that down here at the bottom by choosing the active plane that we're working on. So if I choose to set the active plane to the base XYZ plane, or sorry, base, sorry, just put it back again. I want it to on the base XZ plane. You can see graphically that grid system has now turned vertically on my screen. What it means now is if I place points using the point tool here, what I can do is I can then place it on that vertical plane. Sorry, is there a question there?
No, this is for later. Hi.
Yeah. So we will talk about that later, Paul. Thank you for the question. It's in the last sort of hour of the session, and I'll try to cover it as best I can. Okay, sorry. Let me just close that down. Thank you. Okay, so yeah. So right. So I can create points now. I can quickly sketch these points using the place point command, and I can just place a point on the screen, and I can then you know, space it out the way I want to. And you'll notice down here at the bottom I have an input window. You can do this if you want to do it accurately. I'm just going to do that. You know, I'm going to say it's, you know, it's 3 meters wide, approximately. Okay, now I could do it that way. Sorry, let me just do this. But what I want to do is actually I want to place them clockwise. Okay, so I want to place them sorry, yeah, clockwise. So let me just place the first point again. I'll do this. So place that point there, and then go up from there and just sketch somewhere. Again, stay on that plane, sketch there, and then again, just stay down there. And at the moment, I've created those 4 points. Why have I got 5 points? Sorry. Do apologize. I've just done something similar. Let me just go to the transaction, split it. Yeah. Take those, put them, yeah, delete those transactions. Yeah. Okay. Make sure I do that. Okay. Set that again to there. And what I want to do is place a point. 1, 2, 3, 4. Okay. So I place those nodes, and again, I'm just going to record that transaction. Let me just make sure I've covered all the steps. Yeah. Okay. Now, okay, before I record the transaction, when I'm thinking about downstream, okay, I want clean geometry to be available. And so what I might want to do is, first of all, take these items, right click in here, and you can use the is construction property. Now, what that means is that geometry, when we're working downstream, is it will not draw that geometry as standard. So we know that these node points and these items will be invisible on the final output. Okay, when we generate the node type, it will keep them embedded in the object because it needs to, but they won't be drawn. And that's a really useful tool. So you can begin to separate out, you know, steps, nodes that you've used to actually derive the output from the actual geometry that you want to output itself. So that's a new technique there. Okay. So let me just go back to that. Right, okay. So now what I want to do is actually, with those construction points, is I want to create a polygon from those node points as well. And again, that polygon is going to be a construction element. So I can go to my transaction nodes, go to the polygon node, and they are alphabetical, and it's over here on the right side. Drag that in there, and the default technique is by vertices. Now, when I said default technique, there's a little drop down here, and there are all sorts of different techniques for creating a polygon. And when I choose the technique, it changes the required inputs to do that. So, for instance, if I said from mesh, you will see it wants a mesh input. It wants a predefined mesh element or a mesh triangle in order to create a polygon. If I change it to by lacing, it wants a point, 2 points arrays. You know, it wants a network of points in order to begin connecting those points up in order to build the polygon. Okay, so I'm going to leave this set by vertices. Okay, sorry, my eyesight there. And now all I need to do is connect these in the correct order. So from point 1 to point 2 to point 3 to point 4. And as I do that, you can see the geometry on the left-hand side is building itself. What you'll also notice, okay, if I say is construction, I'll just leave it as being visible for now, so you can see that I've got an item there, is that if I right click here and do edit on that item, those 4 inputs are now listed in the vertex point, but they are now done inside brackets. This is the way that we define a list in GC. So if you have a curly bracket, in standard parentheses brackets, okay, and then separate each value by a comma, you can build a list of items. So you can see there, that's how it's recorded those inputs. And I can edit that, I can change the order, you know, of these by just cutting and pasting them, reordering them if I would. I wouldn't necessarily want to do that. But if I wanted to add more points to this, I'd have to create the point and then, you know, add it into the list in the correct order to make logical sense for that, okay? You'll also notice now, like the other ones, because I've said that this is a construction element, I get 2 new symbols on my node, okay, to indicate that it is a construction element and that it is currently visible. If I right click and make it invisible, you can see it's grayed out, it's suppressed, and it's no longer as highlighted like the other items, okay? Now, so we've got that. So now what I want to do is record my transaction, and I'm going to rename this transaction. It's not necessarily here, but I'm just going to create base polygon. Okay, do that. And I've named that transaction so I can see what's happening within that transaction. Okay. Okay. So this is where we've got so far. Okay. There is an extra step that suggests moving the points around so you get an inclined plane, but that's not an essential step here. What I now want to do is, in order to create the crossbars, I'm going to use the technique of creating a piece of geometry that requires the presence of a center line. So I want to create center lines from the center of the polygon to the outside vertices of that shape. Okay, so again, we have a number of techniques for doing this, and we're just going to quickly run through this. Okay, so let me tab over into the item here. So first thing I want to do is I want to create a point that is either at the center of that polygon or at the centroid of the coordinates defined by the original points. Okay, so again, I go up to the, sorry, I do apologize. There we go. I go up to the place point command, or I go to my node type and I go to point, drag it in, and it defaults to Cartesian coordinates. Okay, so let me just delete that for a second. What I can do is I can right click on the point command and see all of the techniques and choose centroid of set. And then that node automatically gets placed into the graph with that technique preset. Okay, so one of the things I can then do here is the centroid of the set. Well, the centroid of the set is all the corners of polygon 1. Does polygon 1 have a property? Well, look, there's a property there, vertex points. Can I use that? Maybe I can. So go into here, look at the technique, input techniques, pass through. I can click the vertex points and I can just connect that to that. And you can now see I have a point. I know it's very tiny, but there is a point on the screen, okay, in that rectangle there. That is the centroid of that polygon. Okay. Next I need to do is drag lines in here, and what I want to do is connect that center point to each of those vertices again. Okay, so let me go to my line command and choose the by points command, and again over here. So it wants the start point and the end point. Well, I want these to start at the outside and go into the middle. So again, can I do that? Sure. Take this item and go for the start point there. So I'm going back to my polygon 1 vertex points, and I'm going to my center point, center point, and connecting that to the end point. Now, just for clarity, I'm going to rename the center point so I can identify it clearly. Okay, again, that is a construction. These items are constructions as well. These lines that I have created. Okay. The first thing you'll notice is there's another icon on here, and this is the replication symbol. And so what I have, and you also notice that you've got sheets or items here. It looks like there's a stack of nodes on top of one another if I look at that node graphically. That tells me that single node is actually controlling multiple elements. Okay, and you can see here when I highlight it, I get 4 individual lines that are being controlled by that node. Okay, so again, what I might want to do is, again, record the transaction. Okay, and keep those still as constructions. So now what I want to do is I want to create a piece of geometry that follows each of those lines as a center line. I want it to be fatter in the middle and thinner at the outside, but I also want it to be, or vice versa. And I want to be able to control it, not only here, but downstream as well. But initially what I need to do is create a tubular solid or a cone that follows that line. Okay. So let me just go back to my PowerPoint. And have a look at this. So we have a solid item or a technique for creating a solid, and it's called a cone. And we're going to when we create it, we're going to call it a crossbar. And there are some inputs here. Now the inputs, it requires are a start and end radius. Okay. And we'll come to the part section here in a second. So it's very simple. It looks straightforward what we have here in order to create that item. So let me just again create that. So I've got some unrecorded transactions. I'm happy with that because the center lines and the solids are all going to be one transaction. So I'm going to go to my node type. I'm going to go to my solid node, right click, and there should be alphabetically the listing of the technique called cone. Okay, and when I hover over that technique, you actually get a preview of the required inputs, you know, about that cone in order to draw it. So it talks about start point, end point, a start radius, and an end radius. So we've got those building blocks in place, so it should be fairly straightforward to create that. So what I then need to do is think about this. So for my start and end point, so the start and end point here has to be, you know, the start and end point of, you know, line 1. So again, if I wanted to, and I'm just doing this for the benefit of inexperienced users, I'm just going to expose the start and end point inputs as an output. And I'm just going to connect those up. Okay. Now you can still see this little yellow triangle. That yellow triangle tells me is there is insufficient inputs in order to draw the object, or there is something not right with the type of input. You know, I might be trying to input a round peg into a square hole kind of arrangement. There's a mismatch between the type of input that we've linked up. So what it's actually missing is the start radius and the end radius. So if I just put in the start radius, for instance, it's let's say start radius is 200 millimeters and the end radius is 100 millimeters. Okay. You can now see I've got some crossbars in there. Okay. Now these, I want these to be my output. I don't want these to be construction. Now, because I'm in Open Buildings Designer and GC is integrated into the application, there is one other optional property that I can set to help me control graphically what this object is. And that's what we call the family and part definition. So in Open Buildings Designer, we have whole libraries of graphical control to say, oh, you draw objects of this type using, you know, these colors, these line weights, these layers. But we can also say, represent it with a material as well. So again, if I right click on the node and do edit and look down here where it says part, I can go down to the curtain wall definition and draw this or specify the way that this should be drawn, or the material that I should use to draw this is a curtain wall frame. And you can see graphically it's now changed. It looks smoother. You know, if I was to change it to something else, it would change the representation as well. So that's one optional change, and that's a benefit of being integrated into Open Buildings Designer. And you can create your own definitions, because this is also in part potentially a render material if you were doing visualizations as well. Okay, so I've got my crossbars now. I'm going to change the name of the solid to crossbar. Okay, and I'm going to record the transaction as well. Yeah. Okay, and it's in there. So again, if I wanted to in there, I could just say create crossbar. Okay. The choice is up to you, how diligent you were doing it, but it will help you and it will help other users if they have to edit your script, etc. Okay, so let me just go back to PowerPoint, and the next step here. Okay, now one of the things that I need to do is I want to be able, when I use this node, I want to be able to control it downstream wherever I finally use it. So what I need to do is put in some flexible inputs. At the moment, the start radius and the end radius are fixed values. I need to introduce values that can be varied within the script, so that when we generate the node type, those those variable inputs are also exposed as variable inputs to whichever script that I'm using them in. So we have this idea of, or this concept of sliders. And what sliders do is let me set a minimum and maximum value and an increment between those values, and let me choose graphically what value to choose from that. Okay, so we'll go ahead and do that. Okay. Sorry if this is taking a little bit longer than you're doing, but I'm trying to be as open and clear in my communications as possible. So if I go to my node types, this is an area where we go right down into our utilities area, and right down at the bottom in the utilities area, there's a slider. Okay, and the slider comes in and it has some prefixed values. So I'm going to right click on this and now use edit, because it allows me to see items here at a glance and be able to control them and edit them all at once. So I'm going to, first of all, I'm going to change the name, and I can do that at the top here, to start diameter. And I'm using diameter very deliberately. I know that the actual crossbar node talks about radius, and I'm doing something with diameters. I'm doing it deliberately to illustrate yet another way to use or control OBD, sorry, GC. Okay, so for a minimum value, we want to set that to 0. For a maximum value, we want it at 500. Okay, and the current value we actually want to set to 200. Oops, I do apologize. 200. Okay. Now, the snap to ticks, the tick interval and the tick visible, they control what happens in the actual node. So the resolution here, you want to set that to 50. Okay. Yes, you want to switch on snap to ticks, and the tick interval set to 50 again. Okay, and what that does then is when I use the slider, okay, if if I close this now, is when I drag the slider across, you can see the value is jumping in increments of 50, and the slider is actually snapping to those 50 mil increments. Okay. So now, because I'm using this as a variable input, I might want to visually separate that from the rest of the nodes. So what I want to do is right click on the node and say colorize node, and then I can just choose a color, maybe like that, something that is recognizable, just make it a little bit easier. Okay, and click OK. And I've now got an input. What I can now do is copy that node, paste it, and then edit it and saying, change the name to start diameter to end diameter. Just take off the 1 at the end there. Okay. And I'm going to set the value for, so, okay, there we go. Just do that again. Apologies, it's me clicking too early. End diameter. Okay, it's accepted that value, and I'll change the default value to 300 for that. So now what I can do is, once I've done this, is I can then hook these up to the start radius and the end radius. Okay, and it's now taken those inputs and overridden and replaced the previous inputs. Can you see the previous inputs have been removed, and we now have those items in there. So we're talking about diameters for the here in these sliders, and we have start and end radii here. So how do we solve that? Well, we can solve that by simply typing \, which is the divide operator, 2 in there, and doing the same thing with the other one. And it will calculate the diameter, the correct radii for those 2 items. One further step that we need to do, I apologize, I'm trying to go through this as quickly as possible to give you an example, is we need to create the glass that goes into that panel. Okay. And there is, again, we're going to make use of the part definition here to control the symbology of this thing. And what we're going to do then is literally take one of the lines, and we're going to rotate it to actually create the B-spline surface that represents the glass. There are other ways of doing this. I could have, for instance, duplicated the original polygon and created another polygon and converted that polygon into, or applied the material to that that new polygon. So we have a number of options to do this. So I'm just going to quickly do this now. Okay, and let's see. So again, I'm going to go back up to my items, come up with B-spline surface, drag that into there, change it to ruled down at the bottom. I'm going to change its name to glass surface. It doesn't matter what you call it. And you can see the inputs are start curve and end curve. So with this, what we can do is we can simply type in the start curve is line. And you can see as I've started typing line, I'm being prompted to use line 1, which is what we want to use. Okay, so enter to autocomplete, enter to accept that value. But in terms of the end curve, essentially what we can do is we can make use of an inbuilt function, and we have a whole library of functions that I haven't shown you again, that controls how far it actually rotates. And in this case, what it does is it takes one of the lines and rotates it as far as or until it hits the next line 1 element, because remember we have 4 of them. So again, I type line 1 or begin typing line 1, press dot, and then begin typing rotate. Okay, because that is a function that we can do or perform on an object. And then what we do is that function is looking for how many indexes to rotate by, or that's the way I think of it at least. And I just put that in brackets. And what it then does is it creates a new B-spline surface. So you can see one there, one there, one there. So it's literally, it's taken one of the lines, it's rotated it to the next line and built a B-spline surface between those 2 items. Okay. And again, what I want to do here is change the part definition to curtain wall glass or glazing. Okay. So we've more or less now got our, and lastly, I want to record that transaction. Okay, so we've now got our panel, we've got our crossbars, we've got our underlying glass. What we need to do is now create a generated node type. So let me just go back here. Okay, so what we need to do then is look at our interface, and way up at the top here, okay, you can get it, this generated node type. And this is a little wizard that we use to control, how to create a user generated node type. So we want to give the node, the actual node, a name. So I can call it cross bar. Now, to be honest, I've already done this and it's already installed on my machine. So I'm just going to call this cladding panel. Okay, but you can call it crossbar. What it then asks me to do, and I'll zip here, is it then asks me to select either the input or the output properties that I want for this node type. Now, in this particular case, when I select those items, it will logically look at, and actually, sorry, I want these to be visible. Sorry, just make sure that those are visible. Sorry, let me just close that down again. Yeah, those are visible. Just do that again. All right. And you can see when this dialog box is active, we temporarily grey out the graph, because depending on what I choose, it logically tries to work out what it would need as an input or an output in order to produce geometry, etc. And in terms of when I use this node, what I want to do is I want to find polygons in another file and swap that polygon for the underlying polygon that we created in this script so that there is a one-for-one swap. And so if I say input properties, if I say select from GC model, okay, and I zoom in and I find polygon 1, which is my underlying polygon, and I click on that, what it then does, it then highlights for me in the graph what it thinks are mandatory inputs and mandatory outputs in this process. Okay, and it color codes them, and you can see that there's a rough alignment here. So there are a couple of things that we need to do. So let me just type in clad panel again, okay, in the name. So first thing I want to do here is look at the property names. So these property names here are the names or the words that are going to appear on the left-hand side of my new node. So I want to change polygon 1 to simply polygon. Okay, and just start it. And I can here say things like, change that to start diameter. So it's a little bit more, oops, sorry, there we go. Start diameter and end. Sorry, end diameter there. So it's a little bit easier to make those. But then over here, what I want to do is control, what is optional, what is compulsory, are there any initial values? Now, what I have is one polygon. I might want to use this polygon and replace multiple polygons. So I have to indicate that that polygon is replicable. I can't say that word, I apologize. It means that I can use one node to control many nodes in items, okay? The other thing that we need to do is make sure that, excuse me, let me just have a look back at my PPT for a second, remind myself about important things I need to mention. Just doing that off screen for a second. Now, option, sorry. What we need to do is turn on optional, because we might just want a straightforward swap here, or we might want to give the users an opportunity to control this. So where my start and end diameters are, I need to switch on optional, and you can see it picks up the default values for that. Okay, and I'm just going to leave those as they are. It's the default value for those. Now, what we also need to make sure is that the center point and line 1 are construction elements, okay, for those items. But going forward, what I want to do is I want to lock in the node color, the level, and the symbology for that geometry that we're producing. And I want to store this new node type in my working environment so that it is automatically and automatically loaded. Okay. Yeah, okay. And that's all we need to do. And then we can click OK. Now, what that does in the background is, and if you have to give it a second to do the processing and the compiling, is it creates a new node here, and you can see it here in the under the generated node type. If I drag that out here, you can now see that I've got a CAD panel, I've got an input for a polygon, and if I wanted to, I can then expose the start and end diameter for those items. So we've generated a node type, okay, and we now need to go and look at using this, okay. So I'm going to create a new file, and I'm going to call it gc_wall. So I just want to do a very quick exercise just to illustrate how that node would be used. I'm not going to ask you to follow along. I'm just conscious of time. So I'm just going to basically build a network of polygons and use that generated node type to replace those polygons. So I'm just going to work, I'll explain what I'm doing as I go along, so you can see what's happening, but it won't be an exercise that I would expect you to follow. And I might, obviously cut down the explanation. So this is a little bit of going to be a little bit of a speed model, just to give you an example. Okay. So, as always, I begin with a base CS. And what I'm going to do is then create a series of points. So these points are then going to help me create a B-spline curve by poles. So I'll just connect these up in rapid fashion. And what these poles allow me to do is, if I move one of those poles, it allows me to vary that polyline. Okay, I'm going to create a second coordinate system that is offset in the vertical axis. So let me just measure the distance here. Do apologize, I should have. Okay, so that's about 30 meters, that's good. So I'm going to create a second coordinate system, and I'm going to make it about 30 meters above, directly above the first system. So you can see there. Now we have a technique that allows me to take an object and copy it, and have it copied from one coordinate system to another coordinate system. So I'm creating, and it's called by copy transform geometric content. And what this allows me to do is say I'm going to copy the curve, but I'm going to copy it from the base coordinate system to the upper, oops, sorry, have I got that the right way around? Yes, I have. The upper coordinate system. So in effect, I get a duplicate of that baseline. Okay. And again, if I modify the curve, the upper curve mirrors the lower curve. So now what I'm going to do is going to create a B-spline curve by lofting curves, by loft curves. And choose the first one, choose the second one. It creates a B-spline surface. So all of that is construction. Okay, and all of that is invisible. Okay. But what I want to do is I want to create a network of points on that surface so that I can convert those points into polygons. So again, what I'm doing is right click here, and it's a series of points by UV parameter on a surface. Okay, so again, so it's asking me for the surface, that's the surface. And I want an array of sort of 10 points by 10 points. Okay, is that right? Yes. Let me just tick that, make it visible. Okay. It should be visible. Yeah. Maybe I'm not seeing them. Okay, so now I want a polygon. Where's the polygon gone? There we go. And the polygon is by point grid. Enter 10. Oops. Do apologize. Something going wrong here. Let me just open up a backup file and show you how we've actually done that. Browse. Browse, and it was what is it? Polygon surface. There we go. Open that. Whenever you open a file with a script in it, it will eventually ask you, okay, and it's asking me off screen here, if I want to play all the transactions before I can do anything, or just leave all the transactions unplayed. So I'm just going to play them. And you can now see here, let me just, okay, scroll these down. Once it's done. Close that down, bring that down here. Here I have a wall of those cladding panels, and you can see that I've input the crossbar into that system. Okay, and it's replying it. Now, if I control one of those points at the base of the network, I can drag the curve and make it a little bit different, just a subtle change. And at the moment, you can see that there seems to be a difference. The model hasn't updated. The reason for that is I've put in a command that allows me to delay the option for updating the model. So if I go up to here and hit the update model command, it will step through the entire script and make sure that that baseline that controls the model updates the model and realigns it. Okay, so that's very briefly a user-generated node type. I'm just conscious of time, and we've not got an awful lot of time to move on. So and scripting can be quite complex. So I'm just going to go back to this file. Now, what I would encourage you to do is to, sorry, if I just again go back into here. Okay, that, okay. Sorry, that's the exercise that we're going, and you can see there we've been able to input that the generated node type onto that curved surface and control it that way. But just jumping into scripting, so you've heard me talk about the fact that everything has a property. You know, everything in programming terms, you could say that everything is an object, and it has techniques and methods and properties, etc. And you can expose that. And that comes from the basis of GC script being based around C in many ways. So it has very similar behaviors, either to C or C+ or C# in that regard. I think a lot of Bentley products are actually based on C as well, or derivatives of C in order to produce that. What that does is obviously it gives us sort of standardized techniques that are common across the programming development work, and we've tried to exploit that structure to give us things like auto completion, and we can use things like replication, so we can look at lists and then nested lists and various other items. So we leverage objects, methods, and arguments, and we can do those very simply, or we can do those more cohesively. So we do have nodes that have properties, and we can use GC expressions to access those properties and control those. And you've seen some examples of that this morning. But we can also write custom functions, functions that might do calculations and then feed the result of those calculations, downstream, etc. So nearly all of our node types have the opportunity to place by function approach, so that you can script them in some way. The script is a text file. You can actually take an entire sorry, let me rephrase that. So whenever you create a node graph, a node in a DGN file, it's written inside that DGN file, so you can transport it with that DGN file. And so long as if you have the GC application, you can see the node tree, you can edit it, etc. Alternatively, you can actually export the entire graph as a text file that we refer to as a GCT file, a GC text file, and then import that into another session and have it rebuild the graph. So that's also a possibility, because it's an uncompiled text file essentially that we're using. Okay. And in terms of the properties, or the way that we work, we follow the rules from, I guess, from C. In the and you can begin sort of teaching yourself and exposing yourself. Sorry, I apologize for that phrase. Teaching yourself and exposing the capabilities of GC script, and learn from them by following some basic rules. And we have the opportunity within GC to make use of a console in order to either learn or to test calculations before we might use them. So it's a tool that allows us to discover things. So the rules of thumbs are very simple. Okay, variables have to be declared, and they have to be declared with the type before they can be used. Okay. And this also follows for the console, but it also follows in the script editor as well. Okay. So there are standard variable types, and we use a semicolon at the end of a line of coding to indicate that it's the end of the line or the statement. Okay. All right. There are different variables. There are doubles, obviously, which are real numbers. There are numbers that could be an integer or a number, strings, bools, and those are just some of them. There are more, but generally speaking, if you're using text, you can do it in single quotes or double quotes. Either is correct. Okay. And just to say before, examples, you must make sure you declare variables before you use them, and you must type them. So typing is quite important. There is a little bit of flexibility, and you have to input, plan for that flexibility if you want. Okay. There are naming conventions. Excuse me a second. There are naming conventions that we would recommend that you follow, and the naming conventions, everything is case sensitive. So you've got two examples in blue there that are actually considered to be different names and different variables, and therefore independent of one another. You obviously have to pay attention to special characters and etc. And we also have suggest the way that you name variables, the use of camel case or lowercase, etc. The way that you do things. Decide a scheme, the way you're going to do things, and stick to it. We obviously have numeric operators in there. Again, I think we follow the standards that are in there from C in terms of that. And we also follow either PODMAS or BODMAS, depending upon how old you are, in terms of the order of operations, etc. Okay. And we also have relational operators that you can look at in terms of testing values or comparing values. Sorry, I apologize about that typo in there. And we also have the ability to have lists, and we follow the normal data convention that the first piece of data in a list is index 0, and so on beyond that. Obviously, we tend to declare lists using brackets, separated by where the values are separated by commas. But once you've done that, that variable then inherits certain properties or techniques, and we can make use of inbuilt functions like first and last, where you can either pick up the first character, the last character, or the first 5 characters or the last 5 characters in a list. So we're using that object method approach kind of to what we're doing. And then what we have are a number of, we can create functions ourselves, and we have a function node that you can drag and drop into the graph. You can then write the code within that function and return an output, so the output becomes the downstream value that you use in the graph. Okay. And so here are just a couple of examples of that, where once you've placed the function node into the graph, there is a little tool that allows you to edit the item, edit the function, where you can then give it a name. You can put in your arguments or your parameters. You can then do your statements and specify your inputs. So your input arguments become input methods into the function node, and your return parameter or your return output object becomes your output or value from that node downstream. Okay. We do have the ability to, and I know I'm racing through this, but we do have the ability to use code snippets for things like loops and whiles and different kinds of loops, etc., where it will put some copper plate in there for you to actually begin editing code on that. Okay. So for instance, this particular argument, this particular function tests if an input number is divisible by 6. If it is, it increments that number by 1, and that number is then the output. Okay. Here's just a little exercise that I want to show you that we can do very quickly to create a function code. Okay, and what this does is basically this function generates a sequence of numbers that are double the previous one. So it's a geometric progression basically. And what we're going to do is feed that list of geometric progressions into the X value of a series of points, and then build a line that, it spans that series of points. Okay, and then you've got the opportunity at the bottom here, sorry, the opportunity at the bottom to literally change the nature of the geometric sequence that is being produced. Okay, so we're just going to quickly jump into that. So I've actually opened up an existing file that already had a series of transactions in it. Okay, and what I'm going to do is actually highlight those and suppress those. What that means is it doesn't actually read those transactions anymore. So now it's almost like I can start a completely separate script in the same file if I wanted to. So again, I start with a base CS. Oops. Okay, again, there we go. Sorry, it keeps opening off screen. Okay, do that. And then I'm going to go over to my node tree, and where's my function call? There we go. There's my function call. Drag that in there and just open up the script editor. Now I do have the text that I want to do. So I'll just copy and paste this here because it'll save me a little bit of time. Paste it into here. Okay. And I'm just going to make this window a bit bigger so I can see what's going on because it's small on my screen. So we follow the normal convention of indentation. So the function opens up with a bracket. So I need that to indent. Oops, sorry, there we go. And then I need that to indent as well. Okay, and there we go. So that should syntactically be right. But essentially, what this is looking for three inputs: common ratio, an X value, and a count. And these are all defined as integers. Okay. Okay. So we're declaring a variable, and it's an empty list. And then what we're going to do is we're going to add something called X value to that list. But what we're going to do is then initialize a loop based on the value of count. So if count is 10, between 0 and 10, it's going to loop through, it's going to generate the a new value for X, and it's going to multiply the X value by the common ratio. And then once it's calculated that value, it's going to add that value to the list. So if the initial value is 0, we start off with 0, and then it multiplies whatever value there. And then what it does is it returns the list as a series of numbers that we can then use. So that's the function call. So we're going to apply that. And once it's done that, we can then close that window and we can see that we have that function call listed there. And what we need to do is input some values. So if we say that the common ratio value is 2, the X value is, we'll start at 1,000 here, okay? So it's a meter from whatever origin, and we want to do 5 items initially, okay? And just putting in those values, you can now see I've got a list of numbers there. So now what I can do is take a point, or rather take a point. Come on, Brenden. In here. And now, sorry, 0.5, and I'm doing it by Cartesian coordinates. There we go. So what I want to do is, outputs value there. Take the value of that, plug that into the X translation. And as soon as I do that, and I know it's probably hard for you guys to see, so I'll just change the display style, is I get a series of points. Okay. If I change the number to 10, again, I get, and again, it's really hard to see, but I get a series of points in space. I'll drop it back to, I'll change the count back to 5. And I'll change, I'll put that there. But then I can use these points for all sorts of things. You know, I'll just make that a little bit smaller. Yeah, and I can rename that function. I apologize for my appalling typing there, but you can see it's renamed it. But then I can just take a line and change the method by chaining. Drop that down to there. Okay. And so again, if I change the values, say the common ratio to 3, you can see that the spacing changes very quickly. Okay. Now that's, I'm just conscious again. Sorry, I'm just conscious at the time that was a very, very speedily work through GC script. There is an opportunity, and I apologize if you, I don't know if you can see it on my screen. It's a bit difficult for me to see at the moment. But to answer your question earlier, yes, there is the opportunity to package things and use C# and C items. Now, if you happen to have, I think, Visual Studio, the Visual Studio, not Visual Studio Code, but Visual Studio installed on your machine, it is possible to make use of the C# project generator. What that will do is it will attempt to create within Visual Studio a project with all the necessary dependencies and includes set up for you in order to look at creating custom functions or custom nodes using C# as a development environment. I can click on this, but and it starts a wizard, but it's going to fail on my machine because obviously I don't have Visual Studio involved. So I can give it a name, I can hit next, and it's essentially, yeah, so you can do that. And then you've got choice. Is it an element-based node type? Is it a utility? Is it a script function library? So a script function library would be something generic that is not trying to create a specific node. It is providing, obviously automation and programming there. So there's some descriptions there. So if I just said that next, you've got an opportunity here to, add function methods in there with a brief description, and you can begin putting them in there, etc. And then it will generate the C# project files for you with those predefined functions and methods in there waiting for you to do. And it will have all of your import statements set up for you as well. Okay, but as far as I'm aware, it only works with Visual Studio and not Visual Studio Code. You may need the Open Buildings SDK installed on the machine. Sorry, does that answer your?
Yeah, that's perfect. That's perfect. Thank you very much. Can I follow up with another question?
Of course you can.
Is there any marketplace, any official marketplace where you can post those solutions?
No, there isn't an official marketplace at all. I'll be quite honest and open about this. When GC first came out, it was at the very early stages. It was one of the very first products for computational design in the marketplace. And it was a collaboration between academia, some of our Bentley's most advanced users, and Bentley themselves. And it had a niche following for a number of years. Since that's happened, obviously, Grasshopper and Dynamo have come out, and those ecosystems have grown. We haven't grown our ecosystem in terms of having a marketplace and things like that. But we see GC being used in vertical construction. We see it being used in linear construction for computational design along linear elements and alignments and things like that. But an official marketplace as such, no, there isn't one. But we would happily work with you to try and publicize any solutions that you want to get out in the marketplace, be it support through webinars or other vehicles, to get your products out there.
Okay, that sounds perfect. Thank you very much.
Yeah. Okay. I know it's about 20 minutes to 1 o'clock. If there are any other questions, please feel free to ask them now. I will be sharing the PPT if via Abel, and he can distribute sorry, not the PPT, the PDF with all my slides in it. You're quite welcome to that. The one thing, sorry, let me just throw up one more particular slide to help possibly. Sorry, let me just try through that. So there is a user forum on the Bentley communities that's free to sign up with. You don't need anything for that. There are a couple of YouTube channels that have GC content in them. You might have to look around for it. Again, I'll apologize. Bentley users, I don't know if it's something in the nature that Bentley people, Bentley users tend to be or not, but there are not that many users posting videos about using Bentley products across our entire Bentley portfolio, not just GC, but all of our rail and road products. Whereas in other communities, there are lots of people posting videos to help other users. For some reason, our users don't seem to be, keen to do that. But one of our users who is especially in GC is the 5Design YouTube user. That's an architect who uses GC extensively to automate building design, control, and layout. Do that. So you can look at those items. And in terms of learning, I've put a link there to the GC learning path on the Bentley Learn server. The one caveat with that is if you're in education, you may, either as a student or as a lecturer, then you may need to register with the Bentley Education Program to get access to that. Or if you're in commerce, you might need a subscription, and quite often a lot of commercial companies do have subscriptions in place for their staff to actually use. So just please bear that in mind if you're trying to access the Bend and Learn server. I'm going to say thank you very much for your patience with me this morning as I talked through an awful lot of information. Thank you for your time, and I hope you enjoy the rest of the conference and your time this afternoon with Carlos. So I'll finish early and let everybody get to their lunch. So thank you very much, everyone.
Thank you. Thank you so much, Brenden. Although you're here.
Thank you very much, Brenden. Very interesting. I remember the first time I used generative components a good 10 years ago, well, 8 years ago, I think. It looked completely different. So the interface evolved quite a lot. And last year, we were very fortunate to have a keynote from Professor Robert Age, who I think contributed to generative components.
Yes, absolutely. Yes.
Yeah. So it's amazing to see how it evolved over the last few years. In fact, I just received an email from Robert saying, "Oh, please record it because I want to have a look. I'm quite curious." So
I'm sure Robert's depth of knowledge is far exceeds mine already. Anyway, so there we go.
Well, yeah, and but it's the evolution of the tool, and of course you have this pressure from the industry with the new requirements and new processes. It's great to see how it is evolving.
Absolutely, absolutely. And I think there are there's still lots of unexplored territory for certainly on the GC side. I am aware that other products are exploring other ideas and other opportunities, and I'm trying my best to keep up with those. But it's exciting times.
Yes, yeah, and in terms of posting more kind of tutorials and use cases, we can think about how to do that in the Design Computation YouTube channel. If there is of interest, we can have like play sets that show like step by step. It's certainly like a very trustworthy tool, if I may say. It's a very it's the consistency of the geometry. It's fantastic. So it's something we should be talking about more, I think, and have more tutorials. I volunteer, time permitting, I would like to volunteer to publish more of this in the YouTube channel.